myself Dr.N.Ram Babu, working as an assistant professor in the Department of Electrical and Electronics Engineering at the University-Surampalem. We are going to discuss about two-port networks, and in that we are focusing on impedance parameters. At the end of this session, we will be able to analyze the numericals on the two-port networks. So if you look into that impedance parameters equation, the equations are given by V1 equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 V2, where V1 and V2 are the input and output voltages, I1 and I2 are the input and output currents. And in a similar manner, this Z11 and Z12, Z21 and Z22 are called as impedance parameters, where Z11 and Z22 are self parameters and Z21 and Z12 are mutual parameters. In order to find out the values of this Z11, we need to substitute the output current I2 equal to 0. So, if I substitute I2 equal to 0 in this equation 1 and 2, we will be getting the values of Z1 and 2, Z1 and Z12. So, if I substitute I2 equal to 0, that means I2 equal to 0, that means the output side circuit is open circuit and no current is flowing in the circuit. Therefore, if I2 equal to 0 in the circuit, it gives that V1 equal to Z11 I1, whereas Z11 is equal to I1 by V1. So, if you observe this, Z11 equal to V1 by I1. So, self impedance Z11 is given by V1 by I1. At that case, I2 equal to 0. And in a similar manner, here we have substitute I2 equal to 0, right? So, I will be getting the values of Z21. Z21 is equal to V2 by I1. Okay. In a similar manner, if I need to take the values of Z12 and Z22, this I1 should be equal to 0. So, if I substitute I1 equal to 0 in equation 1, therefore, I1 equal to 0 gives rise to Z12 is equal to V1 by I2. That means the input side is open circuited and no current is flowing through the input side. And in a similar manner, V2 is equal to Z22 into I2. Therefore, Z22 is equal to V2 by I2. So, like this, we need to calculate the parameters of Z11, Z12, Z21 and Z22. Okay. Now, let us go deep into the equivalent circuit parameters. So, we all know that V1 is equal to Z11 I1 plus Z12 I2. If I draw an equivalent circuit parameter for this, V1 is the supply voltage, I1 is the current, here Z11 is the impedance and I1 is the current. Okay. Now, this Z12 I2 is the passive element source. Next, V2 is equal to Z21 into I1. Z21 into I1 in the sense the impedance is based upon this primary source impedance. So, that is why Z21 and Z22 into I2. Therefore, Z22 is the self and I2 is the current flowing source. So, this is the equivalent circuit diagram of a Z parameter circuit. Now, let us take into an example and we solve it. So, if you observe this circuit means it is a 1, 2, 3 loop circuit. Okay. So, this problem can be solved in two different methods. Okay. So, first we will be discussing on model 1, that is conventional KCL or KVL. With the help of this we can solve it, and model 2 with the help of these techniques. Okay. This technique we will be going to solve it. So, now model 1, I am following KVL equations. So, see here, this is current I1, this is current I2, I am assuming this as current I3. So, if I write KVL equation over this, V1 is equal to 8 times of I1 plus 20 into, and this current is entering into it and this current is leaving at part. Therefore, I1 minus I3. Therefore, it implies V1 we can write it as 28 times of I1 minus 20 times of I3. I am keeping this as equation number 1. Now, I am writing for this part, loop, middle one. So, therefore, here it is, we can write as 20 into I3 minus I1 plus 10 I3 plus 20 into C. Here both the currents are entering. Therefore, it will be I3 plus I2 equal to 0. Therefore, if I simplify this one means minus 20 I1 here plus 20 I2 plus I3 is 20, 10, 20 again. That means 20, 20, 40, 50. Therefore, 50 I3 is equal to, this is equation number 2. So, if you observe this means, here the complete expression should be in the form of V1 and I1 and V2 I2 and I3 shouldn't be there. So, here I am removing this I3 part. So, 0 will be gets cancelled and here I3 is equal to 2 times of I1 minus 2 times of I2 by 5. This is, I am writing it as equation number 2. Okay, I am deleting this part. Now, I am applying KCL through this loop 3. So, if you observe this part means minus V2 plus 20 20 times of I3 plus this one is entering and this one is leaving. Therefore, 20 times of I2 plus I2 equal to 0. Therefore, V2 is equal to 20 times of I2 plus 20 times of I3. This is equation number 3. Now, I need to solve all the 3 equations. I will write in these 3 equations here again. See, V1 is equal to 28 of I1 minus 20 I3 and I3 is equal to 2 times of I1 minus 2 times of I2 by 5, and the third one is V2 is equal to 20 I2 plus 20 I3. So, equation 1, equation 2 and equation 3. Now, I am substituting this equation 3 in 1 and 2. So, 3 in 1 gives V1 is equal to 28 I1 minus 20 times of I3. I3 is 2 times of I2 minus 2 times of I2 by 5. 5 ones, 5 fours, that is equal to 28 I1 minus 4 twos, 8 I2 plus 2 times of I1 minus this is I1 plus 8 times of I2. Therefore, V1 is equal to 20 I1 plus 8 I2. This is equation 4. Now, if I substitute 3 in equation 2, V2 is equal to 20 times of I2 plus 20 times of I3. I3 is 2 I1 minus 2 I2 by 5. 5 ones, 5 fours. Here it is 20 I2 plus 8 I1 minus 8 I2. That is equal to 8 I1 plus 12 I2. Therefore, if you observe this expression means V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Therefore, impedance Z is equal to Z11, Z12, Z21, Z22. Okay. From this equation 4 and equation 5, it is 28 and 8 and 12. Okay. Like this, we can solve it in model 1. Now, let us move on to model 2, where the equations are as follows. These equations we need to concentrate. Okay. So, for that I am writing these equations here again. V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. First, I am assuming I2 as 0. So, I2 as 0 in the sense V1 equal to Z11 I1 and Z11 is equal to V1 by I1 and V2 will be Z21 I1. Therefore, Z21 is equal to V2 by I1. Okay. Now, let us calculate the values of Z11. Z11 is V1 by I1, but here I2 is 0, that means no current is flowing through it. So, this is completely open part. Therefore, total Z is given by Z11 is 8 plus these two are in parallel, right? In this no current is flowing through it, that means here also no current flows, that means 20 parallel with 30, 8 plus 20 into 30 by 20 plus 30, 8 plus 20 into 30 by 50, 5 ones, 5 fours, 8 plus 12, that is equal to 20 ohms. Okay. If you observe, this means our first one we got the same. Now, let us calculate this Z22 part. Okay. In order to calculate the value of Z22, okay, Z22 is equal to V2 by I2. Therefore, Z22 is equal to V2 by I2. At that time, I1 equal to, that means in this path no current is flowing. Therefore, Z22 is equal to, here it is 20 ohms. Okay. This is in parallel with this 30. That means 20 into 30 by 20 plus 30. 20 into 30 by 50. 0, 0, 5 ones, 5 fours. 12 ohms. Therefore, we got the value of Z22 as 12 ohms. Let us recheck it again. See here. From this model 1 also we got this value as 12 ohms. Now, we need to calculate the value of Z12 or Z21. So, both the values will be remaining same. So, if you observe this from this equation, Z12 is V1 by I2 or Z21 is equal to V2 by I1. So, you can take any of these things. Z12 is equal to V1 by I2. At that time, I1 equal to 0. Therefore, see here, V1 is 20 into I in parallel with 20 into 30. If you solve this means, we will be getting this value as 8 ohms. So, if you cross check means, we got this value as same. So, therefore, in both the methods, we can solve it and we can get all the answers. Okay. we have completed the numericals and the detailed analysis of Z port networks. Thank you.